Hello guys, welcome to Ramta Solutions and welcome to your grade 11 trigonometry. Today in our past papers, we will be looking at your trigonometry written by the Eastern Cape in 2023. So without any waste of time, let's open the paper, solve it. Okay, so here's the paper. So I will just pin this paper. Okay, so here is it. By the way, before we proceed, if you're using a mobile device, please rotate your screen so you have a maximized viewing. Okay, please rotate your screen. This will ensure that you have better viewing. So without any waste of time, let's get into it. Let's see. Okay, instructions, I will not really dwell much on them, but the most important instruction that I want to focus my attention to is this one. If necessary, round off answers to 2 decimal places unless stated otherwise. Okay, and I think I should also mention this. Answers only will not necessarily be awarded full marks. Okay, not necessarily. Okay, so this means that some yes, some no, but try to give a reason or try to reach your answer having shown how you reached your answer. Don't just write your answer where possible. Okay, perfect. So let's get into it. All right, our trigonometry starts in question 4. Okay, our trigonometry starts in question 4. So let's start. So remember guys, if you're using a mobile device, please rotate your screen. Okay, all right. So question 4, let me use a small font size. So question 4, 4.1 says if 7 tan theta equals 7 and cos theta is less than 0, use a sketch in the correct quadrant to determine the value of sin theta plus cos theta over 2 sin theta. They say do this without using a calculator. For this question, the first thing that you need to realize is you have 7 tan theta, okay, which is equal to 3, right? So what is the value of tan theta? As you can see here, what it means is that tan theta is 3 over 7. Now check this out. What was happening here was that, or what is happening here is that tan theta is positive, but they also gave you an indication that cos theta is negative. Where is tan theta positive except the first quadrant? It is in the third quadrant. And of course, in the third quadrant, cos theta is negative. Now let's draw our Cartesian plane. Should I draw it? Okay, let me just, because I don't need perfection, let me just draw it like this. So here is it. Now, we have a point there. Remember, this is tan theta. One thing you know about tan is that tan, let me say theta, is what? Is y over x. In other words, opposite over adjacent. So, we will call this angle here theta. Okay, we will call this angle here theta. So, which side is opposite? The side opposite is this one here, which is 3. But be careful, it's not just 3, it's negative 3. And this side here is negative 7. Right, as you can see, it's y over x. Y is negative 3, y is positive 7. If you're wondering why I'm saying y is negative and x is also negative, guys, this is simply because this angle is in the third quadrant, and in this side x values are positive, or in this quadrant x values are positive, and so are y values, isn't it? So note, tangent is opposite over adjacent, which is y over x. Okay, our y value is negative 3, our x value is positive 3. Okay, cool. Now, we are not done. We should also try to find the hypotenuse. So we will say r squared equals x squared plus y squared. right? So what is r? We do not know. So maybe let's say r equals the square root of x squared plus, oh boy, the square root of x squared plus y squared. Okay, going to the next page. This therefore means r is, what was the value of x? The value of x was minus 7. The value of y, oh boy, why does it keep doing this? Okay, it's fine. The value of y is minus 3. Alright? Value of y is minus 3. Okay, cool. So taking your calculator, this is 49 plus 9, which looks like square root of 58. Alright, which looks like square root of 58. Alright, it looks like it's the square root of 58, isn't it? Since we're not using a calculator, maybe let's just say 49 plus 9. Okay? 49 plus 9. Therefore, r is square root of 58. Okay, r is square root of 58. Happy? Now, we are not done. We are to solve the question, or we can solve the question now. The question said we must determine the value of sine theta, right? Sine theta plus cos theta all over 2 sine theta. So before we proceed, guys, I want you to remember something. This is the first, the second, the third, and the fourth quadrant. In this quadrant, the only sign is positive. Only tangent is positive. So sine and cosine will be negative. So let's see. So we have, what is sine theta? Remember, sine is opposite over hypotenuse, which is y over r. What is y? Our y was, I think, minus 3. Our y was minus 3. Our hypotenuse, we just found that it's the square root of 58, isn't it? Okay, I can leave it like this. Minus, what is cos? Cos is x over r. What is the value of x? It's minus 7. So it's minus 7 over what? Over square root of 58, isn't it? Over square root of 58. Now, this is 2. Again, we said sine is what? What is sine? We said sine is negative 3 over square root of 58. Guys, remember, you are not using a calculator here, right? You are not using a calculator. And by the way, before I proceed, please ensure that you rotate your screen if you're watching this video using your mobile device. Okay, let's go. So we have, let's see, we have the numerator, denominators are the same. So I will put them in a bracket. So it'll be minus 7, minus 3, it'll be minus 10. So it is minus 10 over square root of 58. And the denominator, let's see what we have. Denominator, we have 2 times. Okay, it will be minus 6. 2 times negative 3 will be minus 6. It will be minus 6 over, oh boy, it's doing that again. Minus 6 over square root of 58. All right? Minus square root of 58. So this, when you look at it, remember it's division. Negative divided by negative. What I see, you will be having 10 over 6. When you get to this point, guys, you can use your calculator. Okay? It'll be 10 over 6, but your calculator returns 5 over 3. Okay, your calculator returns 5 over 3. So it's fine. I will just say 5 over 3. Okay, this is your answer. Okay, this is your answer. When you get here as well, you can also write it as, for example, negative 10 over square root of 58 divided by, okay, divided by negative 6 over square root of 58. Okay, then obviously it'll lead you to this answer here. Okay, you can write it in this way as well. It's okay. All right, so this is your answer. This is sine theta plus cos theta over 2 sine theta. Okay. Now, 4.2. Let's get to 4.2. Remember, guys, if you're using your mobile device, please rotate your screen. It says sine what? Oh, it says sine 32 degrees equals P. Okay, it says sine 32 degrees equals P. All right, so I'm going to draw this. This is, let's say here. So this angle here is 32 degrees. Okay, this angle here is 32 degrees. Okay, now they say sine what? Sine P, sine 32 degrees equals P. So this, when you look at it, it's sine 32 degrees equals P. It is similar to P over 1, meaning your hypotenuse is 1. So let's get to 4.2.1. So let me just change this. Okay, 4.2.1, I will just change this. Now we need to find this value here, which we will call our x. So let's say r squared equals, why is he doing this again? R squared equals x squared plus y squared. What is r? R is 1. What is x? It's unknown. What is y? It's p. Right? So this is 1 minus p squared equals x squared. Therefore, this means x equals square root of 1 minus p squared. Okay, I'm not considering the plus minus. Why I'm not considering the plus minus? This is an acute angle. So since it's an acute angle, I will consider it to be in the first quadrant. Therefore, it's okay to take x value as positive. Okay, because it's in the first quadrant. Now, we haven't yet answered the question. The question said we must solve for tan negative 32. Now, let's get into it. Tan negative 32 degrees is basically equal to negative tan 32 degrees. Remember, it's a negative angle of tan. So what do you know about tan 32? Come on. 32 degrees. Here is it. What is it? Tan is opposite over adjacent. So what is opposite it? It is negative, it's P. What is adjacent? And then adjacent will be this x value that we got, which was square root of 1 minus p squared. Alright, square root of 1 minus p squared. Okay, so this is your tan 32 degrees. Okay, I repeat, guys, if you're using your mobile device, please don't forget to rotate your screen. Alright, now let's head to 4.2.2. So 4.2.2, we're looking at sine 418. Sine 418. So guys, sine 418 degrees, when you get to such angles that are greater than 360, and of course it is less than 720, so it's over 1 revolution, but it's not over 2 revolutions, just minus 360 from it. Okay, so for example, you will see 418 minus 360. Okay, what is it? So let me just write it in red somewhere there. Just say 418, that value given, 418 minus 360. I believe you will be getting 58 degrees, right? You will be getting 58 degrees. So this therefore means you can reduce sine 418 to sine 58 degrees. Right? Ooh, you're not dealing with 58 degrees, but I'm going to show you something. Remember, sum of angles of a triangle is 180. This is 90. This is 32. Then this angle here must be, what must it be? It must be 58. Okay, this is your 58 degrees. Okay, so I'm going to answer this question in 2 ways. Okay, I'm going to answer this question in 2 ways. So I'm going to proceed with what I just showed you now. So sine 58, let's go back. 58, what is sine 58? It will be this side here. This side is opposite 58 degrees. Okay, it's this side here, which was x, which is Square root of 1 minus p squared all over, what is the hypotenuse? 1. Okay, let's go. So this is 1 minus p squared, the square root of it, of course, square root of 1 minus p squared. This is your answer, as simple as that. Okay, this is your answer, as simple as that. Alternatively, so let me just say option 2. Okay, let me say option 2. Option 2, sine 418 degrees equals sine 58 degrees. But what you know that sine 58 degrees is basically 90 degrees minus 32, right? 58 is 90 degrees minus 32. Oh, I see 90 degrees. When I see 90 degrees, this changes. It will be cos. Okay, so this will be cos 32 degrees. Now, what is cos 32 degrees? Let's go back to our diagram. Cos 32, angle is 32 degrees. Cos is adjacent over hypotenuse. This is adjacent of 32 degrees. So it is adjacent over hypotenuse. Okay, so adjacent was square root of 1 minus p squared. So our answer is simply square root of 1. Come on. Square root of 1 minus 2p. P squared. Okay, as you can see, these are the same. So it's totally up to you as to how you want to answer this question. Okay? Now, 4.3. 4.3, we're looking at sine 120 degrees tan 300 degrees over cos negative 60 degrees, and then tan 225 degrees. So reduction formula, 120 degrees is in the thingy, is in the second quadrant, so it will be sine 180. Remember, in the second quadrant we went with 180 minus 190 plus. So 180 minus 120 will be 60. So this is 180 minus 60. Now 300ths. So 300ths seems to be in the fourth quadrant. So in the fourth quadrant we work with 360. So 360 minus 300ths, it's still 60. Okay, it's 60. Alright, now cos negative angle of 60. Negative angle of cosine is positive, so it will be simply cos 60 degrees. Tan 225. 225 is in the third quadrant. In the third quadrant, we work with 180 plus. So 225 minus 180 will be 45. So it's plus 45 degrees. Okay, it'll be plus 45 degrees. Okay, it'll be plus 45 degrees. Okay, so now we have sine in the 180 minus, it's positive, so it'll be sine 60 degrees. Tan in the 360 minus, is it positive or negative? It's negative, so it'll be negative tan 60 degrees. Tan 60, it's half. I'm going to come back to this. And then tan in the 180 plus, is it positive or negative? It's positive, so it's tan 45 degrees. Okay. Now, sine 60. Now, if you use your calculator at this point, I think it's okay. Alright, if you use your calculator at this point, it's okay. It'll work. Okay. So tan 60 degrees, what is it? It is root 3 over 2. But I'm not using a calculator because I know this, but I'm going to show you. Maybe let me not do that. Let me show you. Remember, I said to you, we need to do these. So we're going to draw a line, and then we draw another one, and then in between we draw 3 lines. Okay, 1, 2, 3. Right? Then we going to start numbering from here and say 0, 1, 2, 3, 4. Now semicolon, 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 semicolon. and we start at the bottom. 0, 1, 2, 3, 4. Now, all these values should be put in square roots. Okay, all these values should be put in square roots, but you don't have to put 1 and 0 in a square root, right? I mean, it's a waste of time. Because square root of 0 is 0, square root of 1 is 1. Okay, so this corresponds to 60 degrees. This corresponds to 45 degrees. This corresponds to 60 degrees. Okay? So these are x, y. And by the way, r is always 2. The distance between these guys is 2. Okay, the distance between these guys is 2. Okay? So this is the hypotenuse. It's 2. So let's go back. Sine 60, we're gonna go to the diagram. This is the 60 degrees line. What is sine 60? Sine is y over r. What is y? Y is this. Remember I said this is x, this is y. It's root 3 over 2. Okay? Now, what is tan 60? Let's go back. Tan 60. Tan is y over x. It's root 3 over y. Even your calculator will return that. So it's root 3, negative root 3. Okay? Now, he said cos 60 was half. Let me just show you. Cos 60 is x over, cos is x over r, 1 over 2. Now we have tan 45. Tan 45, tan is y over x, root 2 over root 2. That is y. Okay, so this is y. Okay? Perfect. Now, further simplification of this, root 3 times negative root 3 will be 3. So this is 3 over 2 all over half. So let's do that. This is negative 3 over 2 over half. So what is our answer? Our answer is simply 3. Is it 3 or negative 3? Our answer is simply negative 3. Oh boy, this thing, don't know why it keeps doing this. Okay, it's fine. Much better, right? So what is our answer? It's negative 3. So guys, if you put this as it is in your calculator, it must give you negative 3. If it doesn't give you negative 3, it means your answer is, okay? Means your answer is right. Perfect. Now, 4.4, prove this identity. Now, in proving this identity, you need to look at this. Of the two, which one is simple to break down and which one is not simple to break down? Agree with me that the left-hand side seems simple to break down. So we're going to use it. Okay, let's go. So we begin by saying left-hand side. I like saying left-hand side is Little Toddy High School. Yes, this is Little Toddy High School. So it is cos square x. Oh boy, that's the root again. Cos square x minus cos x minus sine square. This the root, right? Minus sine square x all over 2 sine x cos x plus sine x. Yeah, that's the root. Okay, and another thing, guys, I need to tell you, you are not the one that said this question paper. I saw that you write in a way that makes sense. Don't try to, whenever you answer questions, try to remember what the last question paper was saying. Hey, you did not set this question paper. Let things make sense. Answer questions orderly, or let's call it analytically, in an order that would make sense to anyone who will be looking at your answers. Okay? Don't try to be super, I'm going to say super smart, or I don't know, super complicate things. Just do things orderly. You will never be disappointed. Okay? Perfect. So I will say, for example, now we need to reduce cos square. We're going to reduce sine square x because I see here we have a common factor. So since we have a common factor of sine x, maybe we need to work with cos all together here and not have any sign. So I'm going to reduce sign. So it's going to be cos square x minus cos x minus, I know sine square x is 1 minus cos square x. Of course, this was all over 2 sine x cos x plus sine x. All right? So now this, I simplify it. When I simplify it, it'll become, it's up to you guys if you want to break the brackets first, but maybe let's break the brackets first. I know it'll take longer, but please, let's just break the brackets. You know, these two, when it does this, it looks like I'm cancelling. X minus cos x minus 1 plus cos square x all over 2 sine x cos x plus sine x. All right. So now, as you can see, we now have 2 cos square x. Oh boy. 2 cos square x minus cos x minus 1 all over 2 sine x cos x plus sine x. Now, as you see, this numerator is a trinomial. Now, this trinomial, it looks like we can factorize it. Indeed, we can. It'll be 2 cos x, think cos x, let me say minus 1 for now, and then it'll also be cos x minus 1, but because I see the middle term is negative, this guy must be positive. Now, denominator, I'll factorize. Sine x is a common factor. I'm left with 2 cos x, 2 cos x plus 1, isn't it? 2 cos x plus 1, as you can see, these guys are cancelling, right? These guys are cancelling, right? So what am I left with? I'm left with cos x minus 1 all over sine x. Let's go to the next page. We are left with cos x minus 1 all over sine x. Now, what you are seeing here is that you have cos x over sine x, oh boy, minus 1 over sine x. Now, what you know, guys, tangent is sine over cosine. But now this is cosine over sine, so it means it must be reciprocal, which is 1 over tan x. This stroke, it's annoying now. Right. Minus 1 over sine x. Therefore, isn't this equal to the right-hand side? It is equal to the right-hand side. I like calling it Rustenburg-Wurst School. Okay. I like calling it Rustenburg-Wurst School. So, yes, Rotary High School is equal to Rustenburg-Wurst School. Yes. This is Bokonivo Karima for you. Okay, guys. So, now let's now go to 4.5. I like this 4.5. Now, this 4.5, the reason I like it is simple. This is sine 5 theta. It is equal to cos theta minus 40 degrees. So normally, when you look at this, it's when they say point of intersection of two graphs, f of x is equal to g of x. Okay, and because this is trigonometry, we will say, I can make the right hand side or the left hand side to be, what is this? To be sine or to be cosine. So I want to work with sine. So I will make the right-hand side to be sine. So what I know is that I will say this is similar to saying it's sine. Oh boy. Sine. Now what is this? 90 degrees minus, open bracket, theta, minus 40 degrees, close. All right? So now, sine theta is equal to, when you look at this, it's sine 90 minus 40 degrees, 90 plus 40 minus theta. But let me just do this, 90 minus theta plus 40 degrees, isn't it? So now, it was sine 5 theta, So sine 5 theta is equal to sine 90 plus 40 degrees is 130. So it's 130 degrees minus theta, isn't it? So I'm going to say, let's try to consider this to be maybe this 130 minus theta. I will think of it as a reference angle. So in other words, when I proceed, I will say sine, as you can see, sine 5 theta is equal to sine 130 degrees minus theta, meaning sine is positive. So sine is positive in the first quadrant, right? In the first quadrant, we will say 5 theta is equal to what we termed our reference angle, which is 130 degrees minus theta plus 360 degrees k, where k is an element of an integer. Okay, so this means 6 theta is equal to 130. This 6 theta is coming from the fact that the theta went to the other side. So it was 5 theta plus theta, which is 6 theta. Okay, plus 360 degrees k. So 130 divided by 6 is 21.67. Okay, is it so? Yes, 130 divided by 6 is 21.67. Isn't it? I don't know, guys. You guys can confirm. So 130. So theta divided 130 divided by 6, right? 130 divided by 6 is 21.67. It's 21.67 plus 360 divided by 6. It's 60 degrees K, isn't it? It's 60 degrees K, isn't it? Now, sine is also positive in the second quadrant. So we go into the second quadrant. So in the second quadrant, we know the reduction formula. We work with 180 minus. So it will be 180 minus that reference angle of ours, right? Plus 360 degrees K, where K is an element of an integer. Okay, so this is 5 theta equals 180 degrees minus 130 degrees plus theta plus 360 degrees K. So this is 4 theta. It'll be equal to 130 minus 180 rather, 180 minus 140, 180 minus 130, it'll be 50. It'll be 50 degrees plus 360 degrees K. Now, theta will be 50 divided by 4. 50 divided by 4 is 12.5, right? It's 12.5. Okay, it's 12.5 degrees plus 360 divided by 4, it's 90 plus 90 degrees K. Okay, plus 90 degrees K. All right. So this is how we solve this question. Okay, this is where these points, these graphs are intersecting. All right. This is where these graphs are intersecting, and this is your general solution, of course. All right. Perfect. Now, if you have not yet done functions, rather not, is it functions? No, if you have not yet done application, because it's, say you're watching this video before the third term, you don't have to watch this video from this point onwards. But if you're watching beyond the third term, guys, now we will do question 5. Now question 5 says, in the diagram below, PQ is a vertical tower. Q, R, and S are points on the same horizontal plane, okay? The angle of elevation from R to P is theta. I can see that. Angle QRS is 120 degrees. I can see that as well. PQ is equal to RS is equal to X. Okay, cool. I can see this. All right. Now determine QR in terms of theta and X. Where's QR? Okay, here is QR. So in terms of theta and X, okay, this is angle theta. We're looking at this side. What is this side to angle theta? It is adjacent. What is this side? It is opposite. So we must use tangent. Okay? So we must use tangent. So we will say, and this is 2 marks. This is tan theta equals equals PQ, because it's opposite, equals PQ over, what is this? QR. Over QR. Okay? So it's okay. Tan theta equals, what is PQ? PQ is X. What is QR? We do not know. Therefore, this means, oh man. Therefore, this means QR is equal to X over tan theta. Okay? QR is X over tan theta. Remember, guys, if you are using a mobile device, please rotate your screen. Okay? All right, I think I should reduce the font size here. Sorry, buddy. Okay, now 5.2. Okay, yeah, 5.2. So 5.2 says, show that QS is equal to X multiplied by the square root of 1 over tan square theta plus 1 over tan theta plus 1. Okay, so how do we do that? So to get QS, we have this side, we have this side. So we have 2 angles and an included side. We need to use cosine rule. Remember, cosine rule said A squared equals B squared minus, oh boy, that's triple K, B squared plus C squared minus 2BC cos angle A, right? But in our case, we're not going to write it in that way. We're going to say this is, what is the side that we're looking for? QS. So square root QS squared equals, what is B squared? It doesn't matter. I will say it is RS. So it is RS squared plus QR squared, okay, minus 2 into RS into QR multiplied by cos. Be careful. It will be cos angle QRS. Don't just say cos R, unless you have said in triangle. Maybe if I say in triangle QRS, okay? If I said in triangle QRS, then I can say angle R. But if you didn't write the statement of in triangle QRS, you will need to say cos angle QRS. Okay, you will need to say that. But because I had said this, I don't have to. So what is QS? We do not know as yet. What is RS? RS is X squared. What is QR? QR is, oh boy, what is QR? QR is X over, it's X over tan theta, okay, square, minus, oh boy, I won't have space, so let me just squeeze it here, minus 2 into, what is RS? It's X. What is QR? We said it's X over tan theta, right? X over tan theta. And then what was angle R? It was 120 degrees. It was 120 degrees. Okay? We are not done. Proceeding. Now, QS squared will be x squared plus x squared over tan square theta, isn't it? Tan square theta. Oh no. Tan square theta. This will be minus 2x squared over tan theta, isn't it? Minus 2x squared over tan theta. But we need to be careful. This is 120 degrees. We can write it as an acute angle. So I will say it'll be cos 120 is in the second quadrant. So 180 minus 120 is 60, isn't it? It's 60, right? It's 60. So this is 180 degrees minus 60 degrees. Proceeding, QS squared equals x squared plus x squared over x squared over tan square theta minus 2x squared over tan theta. This becomes negative cos 60 degrees, isn't it? Proceeding, QS squared equals x squared plus x squared over tan theta minus 2x squared minus 2x squared over tan theta. Now, what is cos 60? Is half. But negative cos 60 is negative half. As you can see, these guys will be cancelling. We are left with QS squared equals, I'm not factorizing, is it? 2x squared equals x squared plus x squared over tan, oh, I forgot the square here. Tan square theta plus, plus what? X squared over tan theta. Okay, so there's a common factor as well, but it's okay. There's a common factor, so I'm sorry it's taking a bit longer, but yeah, why not? I don't want to rush into things. So common factor here is x squared, and then I'm left with 1 plus 1 over tan square theta plus 1 over tan theta, isn't it? Now, what is QS? QS is the square root of this guy. So square root of x squared will be x, and of course square root of these whatever that is inside the bracket will be 1 plus 1 over tan square theta plus 1 over tan theta. Remember, it's the square root. Okay, so this is your answer. Oh boy, I have to change the writing. I don't like it. It's not visible enough. Right, it's not visible enough. So let me do this. Okay. So here is it. We have proved this, right? We have proved that QS is equal to this. All right. Oh my. Now 5.3, much better. 5.3, if x is 15 centimeters and theta is 22 degrees, calculate QS. Okay, calculate QS. That's fine, eh? So we need now to calculate QS. Oh, nice, eh? So we know QS, we just calculated it. QS was x into y over tan square theta plus 1 over tan theta plus 1. Now, what are they saying? They're saying to us that x is 15 centimeters. Okay, then theta is 22 degrees, so it's tan square 20. This guy, tan 22 degrees plus 1 over tan 22 degrees plus 1. Remember here, guys, in this section, you use your calculator. Don't stress about anything. Okay, you use your calculator. So let's get our answer. I don't even have to simplify this. It's 2 marks. So our answer is 15 times the square root of 1 plus 1 over tan 22 degree close bracket square plus 1 over tan 22 degrees. Our answer is 46.48 centimeters. Remember, write your answers correct to 2 decimal places unless stated otherwise. 46.48. Okay, 46.4. Oh boy, I nearly said degrees. Centimeters. Right? So it's 46.48 centimeters. Right. Now, proceeding. Now, 5.3.2 says, determine angle QPS. Where is it? Where's angle QPS? Oh, here is it. So QPS is here. So it's right angle triangle. Angle QPS is here. We have QS and we have X. Okay, cool. So angle QPS. So it means we must use tan QPS. Okay, so I will say this is tan angle QPS equals, what is opposite angle QPS? It's QS. Okay, it's QS. Oh boy, it's QS. And what is adjacent? It's PQ. Right, it's PQ. Right, so cool. So tan QPS is equal to, what is QS? QS is 46.48. And what is PQ? PQ is X. The value of X was given to you as 15 centimeters. Right, it was given to you as 15 centimeters. So I won't waste time. I will simply say angle QPS is tan inverse of 46.48 over 50, and then get my answer. Okay, and then get my answer. So shift tan inverse of 46.48 over 15. What is it? This is 72.11. 72.11 degrees, because you are looking for the angle. It's degrees. Okay. Perfect. Right. So, all right, we good. Now we can head to, let's see, the next question. Oh, I like these functions. Are my favorite. Then I don't like drawing. So let me try to reduce this guy. I think I don't have enough space. Okay, that's better. Yeah, if I have to zoom him out. Okay, now let's go. Now we look at question 6. So question 6, okay, question 6 says, given f of x is equal to sin 2x and g of x is equal to tan x minus 1, draw a sketch of this guy on the same set of x's and provided in the answer book. We don't have that. For x is an element of 45 degrees to 180, indicate all endpoints, intercept with the x's, turning points, as well as asymptotes. Guys, this you can use doing your calculator. So I'm going to guide you first in your calculator. You will say f of x equals sine 2x. Okay, and then g of x equals tan x minus 1. Of course, you must be showing this in your calculator, or your calculator shows this. Okay. I'm going to use my Casio calculator because most of you use Casio. So we do that in our Casio, and we also go there. So sign open bracket to alpha x. Of course, you guys must know how to do this by now. And then turn alpha close bracket, which is alpha x, and then minus 1 close bracket again, minus 1. Then your start, okay, your start will be negative 45, okay, and then your start will be negative 45. Your end, as you can see, this is, let me zoom this in, your end will be 180. Okay, your end will be 180. Okay, your end is 180. Now, what is your step? Your step, guys, this is sine 2x. So this must tell you that your step must be 90 divided by 2. Okay, it must be 90 divided by 2, which is 45. So your step is 45 degrees. Okay, your step is 45 degrees. If you do this, trust me, you will never go wrong. Okay, your step is 45 degrees. Then you can start drawing. Okay, then you can start drawing. So let me not waste time. I'm gonna use a grid. I'm gonna use a grid. Yes, I'm gonna use a grid. It's fine. Let me use a grid. So as I use a grid, because I want to make sure that I'm drawing the right thing. Let me see. Okay, I'm using a grid, so let me start here. Guys, it's important, but because this answer sheet is provided, you won't really struggle. So yeah, you won't really struggle. But what I'm going to show you is something that you must do. Okay. Okay, let me start. So I'm going to take this as 0, and this will be negative 45, and this will be 45, this will be 90, this will be 135 degrees, of course. Okay. And this will be 180 degrees. Guys, I want you to pay attention to the distance between 2 points is 2 lines. Can you see that? It's 2 lines. I want you to do the same even on your vertical scale. So it'll be 1, it'll be minus 1, and then I know this thing goes up to 2, but who cares? It can even go below negative 2, but I don't care. So your calculator has given you, for f of x, for example, it says f of x, when it's negative 45, it's minus 1. Here is it. All right, here is it. When it's 0, it's also 0. When it's 45, it's 1. When it's 90, it must be 0. Right? When it's 90, it must be 0. When it's 135, it's minus 1. Where is it? 135 is minus 1. When it's 180, it's 0. Do you see this? I'm plotting this as if you are still in grade 10. So then you join these points. Okay, so then you join these points. Right? So you join them. Really? Right? Perfect. So this is f of x. Okay? This is f of x. Let me write it. Okay. This is f of x. Okay? The black is f. Okay. Now, let's go to, I'm going to change the colors for G. For G, so for G, I'm going to change color. Let me use the red. I want you to know, what I know is that at 90, you will get an error. Okay, at 90, you'll get an error. So at minus 45, you have some negative 2. Let's say it's somewhere here. And then at 0, you have 1. At 0, you have 1. Is that so? Yes, at 0 you have 1, and then at 45 you have 0. At 90, this does not exist at 90. Okay? And then at 135 you have -2. Let me say it somewhere here. And then at 180 you have -1. Be careful. At 180 you have -1. So our function moves something like this. Okay? This is your tangent. Okay? It should never touch this. And then here, it's going to be like this. Okay? It's going to be like this. Okay? It's going to be like this. Something like that. Okay? It's going to be something like this. So now, cool. They say, now use your graphs to determine the values of x for which sine 2x is greater than 0. By the way, I should say this one is G. So they say use your graphs to determine the values of x for which sine 2x is greater than 0. I'm going to go into the next page. I'll show you what it means. 6.2.1 is to say, let me do this. You have sine 2x is greater than 0. What does it mean? It means f of x is greater than 0. Okay, it means f of x is greater than 0. Let's go. Check it out. Where is f of x greater than 0? F of x greater than 0 says y value of f is positive. Why is it? Look at it. Oh, to the left of 0 degrees. To the right, yes, until 90 degrees, right? So what's happening? When x is greater than 0 degrees but less than 90 degrees, look at it. F is positive, meaning its y value is positive. Okay, so this is when x is greater than 0 degrees but less than 90 degrees. Right? All x values greater than 0 but less than 90. F of x is positive. 6.2.2. So 6.2.2 is this through. 6.2.2 says f of x times g of x is greater or equal to 0. Meaning, 1 here, f of x, okay, times g of x is greater or equal to 0. What does it mean? It means both must be positive. Okay? Both must be positive. Both must be negative. Okay? And one or two must be 0. Either is 0. Because you know, any number multiplied by 0 is 0. Oh boy. And either is 0. Either of them is 0. Come on, man. Oh, man, I'm having a tough time today. And either is 0. Right. So we're going to look at this. Remember, both are positive or both are negative, and either of them is 0. Let's go to our diagram. Ooh, to the right of 0 degrees. Right at 0 degrees. In fact, both of them are 0. So cool. Now to the left of 0 degrees, what's happening? To the left of 0 degrees, both are negative. Cool. We will take that. So this is when x is greater or equal to negative 45 degrees. Right? But less or equal to 0 degrees. Right? Now, as we go to the right of 0 degrees until 45, it doesn't work. Again, as we go to the right of 45 degrees or between 45 degrees and 90, it's working. How many marks is this? 3. Or between 45 degrees and 90, it's working. But be careful. One of them does not exist at 90. So I'm going to show you. When x is greater than 40, here is it, x is greater or equal to 45 degrees, but less than 90 degrees, right? I'm saying less than 90 degrees because one of them does not exist at 90 degrees, which is your tangent, okay? And what else do we say? Again, when x is greater than 90 but less than 180. Remember, I said both must be positive or both must be negative, and either one of them can be 0. Even if it's both, it's okay. Okay, so now when it's greater than 90 but less than, less or equal to 180. Or, or x is greater than 90 degrees but less or equal to 180 degrees. Then this is us answering the question. Okay, so guys, the reason I'm saying both positive or both negative is because remember this thing was saying f of x times g of x is greater or equal to 0, right? So what we know, positive times positive is positive, negative times negative is also positive, and this is why what we are saying is correct. Okay, this is why what we are saying is correct. All right, perfect. So 6.3, so 6.3 says h of x is f of x plus 2. Write down the range of h. What we know here is this. You can get it directly. As you can see, this is, let me show. Okay, as you can see, this is, what is it? It'll come back. This is 2 marks, right? This is 2 marks. So what you can do, you can get your answer directly, but I don't want you to guess. I want you to know how you get your answers. So h of x equals f of x, right? H of x equals f of x plus 2. What was f of x? If you recall, f of x was sine 2x. Do you guys remember? Plus 2. Now, what is the range? When it was sine, let me go back to the diagram. When it was sine, look at the range. It was -1 and 1. But now, what has happened? It has now been shifted 2 units up. Hear me out. It's the very same graph, but it has been shifted 2 units up. When it gets shifted 2 units up, everything will be 2 units up. So what is the minimum value? Minimum value is -1. But when it's shifted 2 units up, it will be at 1, 2. So minimum will be at y. All right. So we will say y is an element of, because it touches that, it will be at 1. And then what is maximum? Maximum was at 1. So it needs to shift 2 units up. Can you see? Maximum is at 1. It needs to shift 2 units up. So it will be 1 plus 2. What is it? 3. So this is your range. Okay? This is your range. So guys, this is how you attempt your trigonometry. Okay, this is how you attempt your trigonometry. I need to sort this guy who's been giving me a tough time. Somehow he's been making my writing to be super slow. But it's okay. So this is how you attempt your trigonometry. So with that being said, I was end here and see you next time. So, bye-bye.